how to select the project, how to finalize it, and how to develop a project charter and a high level process map. So at the end of the define phase, the participants, is my screen visible, my voice audible?
Yeah, it's audible.
Yes, sir. Yeah.
Yes, sir.
Okay, so at the end of the define phase, we are going to get a approved project charter followed by high level process map. Okay, the project charter is the important document for you to carry throughout the project. Every development, every modification, improvement which you made during each and every phase must be written, must be done in the project charter and properly approved. Okay, now we move to the measure phase. Okay, what is the measure phase? Why we need to follow this phase? See, normally I used to say a statement: anything which cannot be measured cannot be monitored. So if only you measure things, you can monitor. If you only you monitor, you can control it. If only you control it, you'll be able to direct it. So measurement is critical. Measuring is very important. So what we are going to see in this measure phase? See, in the measure phase, we are going to check whether we have identified the inputs and the outputs. Okay. So the measure phase, definitely we should know what is the output required and what is the input we have. So for that we need to measure. Okay. Then we have a current measurement system. Okay, whether the current measurement system is adequate. For example, if I want to measure 0.01, is my vernier caliper or screw gauge is capable of measuring that accurately? That refers to capability. For example, if I want to measure 20 centimeters, or if I want to measure a temperature of 50 degrees centigrade and I have a thermometer which has only 40 degrees, it is not adequate, right? So I need to have a measurement system which is capable and adequate to measure the input and the output of the existing system. Without proper measurement system, it is very difficult to measure the existing parameters metrics. So I need to check and make sure that I have a proper, capable and adequate measurement system. Okay, then data collection plan. Data collection plan is very critical.
Excuse me, sir. Sorry to interrupt you. I mean, I could find some disturbance in your voice. Is this with me or?
Same here.
Yeah.
Same here.
Sir, I request you to just check it up with your headphones once, sir. Your voice is also very low.
Okay.
Yes, Ravi, some noise was coming in between.
Is it okay now?
Looks good.
Your voice is still quite low.
Hearing some humming noise in the background when you speak.
Is it fine now? What about the voice now? It is okay?
Humming is still there, sir.
It's still there.
It's still there.
Can you try without that, what do you call the earphone?
Capability refers to the accuracy and precision which we can measure a data. Okay, and adequacy refers to the range which we can measure. Okay, then we need to have a proper data collection plan. What is this data collection plan? See, we need to know how to collect the data, at what time, at what shift, or at what conditions. Okay, everything has to be properly informed to the inspector or the data collector or the member of the team. We need to have a proper data collection plan. Then only the measurement, the data which we have may be used for the analysis, may be used for calculating the performance. Okay, then so followed by it, you need to check, is the data collected appropriate, whether the data collected, is it appropriate for analysis for my system. See, we have to make sure we have collected some data. My inspector, my quality inspector, my team member has collected a data. Whether the data is appropriate for analysis, for that we need to check the data collected using a MSA or AAA. You are going to learn about all those things in the detailed manner. Okay. Then followed by, see, after collecting the data, you are going to calculate the performance. So now you know what is the required performance and what is the gap. So how far is the project goal from the current performance? See, for example, if I want to reduce the invent cycle time I want my cycle time to be around 4 hours, 240 minutes. But currently the cycle time for a particular assembly of the component is nearly 2 hours 70 minutes. So now I know my target is should be around 240, but my current performance is 270. So the gap is nearly 30 minutes. It is going to be around nearly 10 percentage, 15 percentage lower than my current my record performance. So you need to measure to find out the gap in the current performance. Okay, so this is what the measure phase will help you to do. Okay, so to do this,
Sir,
yeah.
sorry, I didn't get that. Is data collected is appropriate or not for the analysis? Can you just elaborate? Sorry, I didn't get.
Actually, as I told in the initial stage itself, this information which I am providing you will create a lot of doubts. It may have an outline only. All these things you are going to learn in different phases, in different sessions in a detailed manner. Okay. So for example, I am collecting a data. Okay. So for example, we need, for example, if a patient is, for example, if a person is having a doubt that he may have corona, what he does, he goes to a hospital, he gives the samples. Okay, for example, the COVID sample has to be collected from a particular nose or from the throat. For example, if the sample is collected from the fingers using a blood, whether it is going to give the initial information, that data is completely inappropriate. It is not at all relevant to the process which I am going to use. So I am going to check the availability of a particular virus, but this blood may give a lot of different informations. It is not going to give a relevant information which I am seeking for. It is completely inappropriate for the process which I am going to use. So the data will be there, but it may not be relevant to the process for which I am going to work on. Okay, so no need to worry. As I told you earlier, you may have a lot of questions now. You may have a lot of doubts rising out of your minds because all of you are working professionals. But everything is going to be clarified in the next 3-4 days in a detailed manner. So don't worry about it. Just get all.
May I come in? May I come in, sir?
Yes, please come in.
Gentlemen, the presentation is only overview again. You have got 6 days. And I understand that you definitely will have a doubt because every time we are saying that you will know about it, you will know about it, and about at least about 100 items we have told so far. We will teach you these things. All these
no issues, sir. Please continue. No issues, sir.
Right? Thank you. Thank you very much.
Yeah, that is what I told. It is just going to be a teaser for a film. For a 3-hour film, the teaser is 2 minutes. For a 48 and for the next 42 hours class, it is just a 1 hour teaser. So don't worry about lot of sessions will be there to clarify your doubts. You'll be having activities, you'll be having interactive activities also to learn more on all these things which I am giving you a preview. Okay.
So sorry, I have a fundamental question from this particular slide. Can you please go back? So the last step here says how far is your project goal from the current performance. So will we not get this particular assess through into the analyze phase?
So actually, in the project charter, we have a column called project goal. Okay. So in the project charter slide, I show you a template. There we have a column called, we have a small box called the project goal. So we fix a project goal. Okay. It may be quite tentative. Okay. So we will check our current performance with the project goal. For example, I want to reduce my inventory from this percentage to this percentage. That will be the project goal, because during the defined phase itself, when we get the approval for the project goal must be present there. Then only the top management will approve your project, right? So there we have a project goal, which will be more or less focusing, which will be more or less help you to focus on the project. So now you measure the current performance in the measure phase, and now you'll be able to find out where is my project goal and where is my current performance. Okay, you'll be learning all these things in 3-4 sessions in half an hour, 1 hour sessions. So no need to worry. So as I told you earlier, you will have a lot of questions in your mind. You will have a lot of doubts rising out of your mind. All these things will be clearly explained. As already told by Dr. Ramakrishnan also, this is just a preview. For a 3-hour movie, I am giving a 2 minutes teaser. So definitely after looking at the film only, all these doubts will be clear. So the film is going to happen for the next 4-5 days. So no need to worry, no need to jump into questions. Just listen, have all those questions in your mind. Everything will be cleared by the entire team of experts. Okay, sir?
Let me come again. Let me come again, RK.
Yes, sir.
Okay,
Keep coming.
Gentlemen, I will give a direct answer for you now. Now, suppose in the defined phase, I am saying that you are getting a profit of only 10 rupees. You are getting a profit of 10 rupees. And then I am giving a project proposal saying that I am going to make it to 20 rupees profit. Okay. That is what the defined phase. Now in the measure phase, I find because I have a perfect measuring system, your profit was not 10 rupees earlier. It was only 5 rupees. Right. Now I have understood the real gap. It is not 10 rupees I'm going to show you. I'm going to increase the profit by 15 rupees. Clear? This is what is this sentence means. Then in the analyze phase, we are going to make sure that you're getting 15%, 15 rupees profit. Clear?
Understood.
The different phase, I promised you, I told you that you are getting only 5 rupees profit, 10 rupees profit. And then I said that I'll give you 20 rupees now. But in the measure phase, I found that the 10 rupees I was telling you initially as your profit was not correct, because with the accurate measurement system, the profit is only rupees 5. So then what is my project? My project has got a better value now, because I'm going to show you 15 rupees increase from 5 rupees to 20 rupees, not from 10 rupees to 20 rupees. And analyze phase is completely different, right? This is measure phase. We are going to say something. We are going to ensure that whatever we have said is true or not. That is what this statement says, right? The gap was 10 rupees earlier. Now the gap is really 15 rupees now. Thank you.
Okay, so like this explanations, you are going to get a lot of sessions. So don't need to worry. As I told, it is just a small preview, outer line, a blueprint. So don't worry. Keep all your questions. If it is not answered in the next 4 days, definitely you can raise them at any sessions. It's okay. Okay, now we have a small video. Just have a look at it. From that particular video. So actually, a bowler has bowled a ball to the batsman and the umpire has not given out. Okay, umpire has not given out. He has measured it using his own measurement system. So after that DRS review, it is found that the measurement system which he has used is incorrect. So as a result of that, the particular batsman was given out and the outcome of the entire match changed. So this is what can happen if we doesn't use a proper measurement system. See, for example, if Mahendra Singh Dhoni, if he has not gone for a review and if he has stick to the measurement system, what the umpire has given to him, what will be the result? He would have lost the match. The match will be a failure to him. So since he checked the measurement system used by the umpire using a DRS review and he found that it is incorrect and he got the verdict changed, and as a result of that he was able to be successful in that match. So what do you understand from this? If he doesn't check the measurement system, if he doesn't use a proper measurement system, the data which we may got at the end of the particular phase may be wrong. It will lead you to a wrong outcome, a failure outcome, a disastrous one. So you may entirely lose the way of the project. So the measurement, in the measure phase, the measurement system is very important. Okay, and the way to analyze the measurement system is also important. So you need to make sure that you are using a proper measurement system. Then only the data which you have collected will be correct. The data which you have collected will be appropriate for analysis. And finally, you'll be able to find out the performance gap between your goal and the current performance. So measure phase is very critical. In defined phase, defining is very important. Defining of the problem is important, but measuring of the problem is very critical, because if you doesn't measure it properly, as told by Dr. Ramakrishnan sir, see, my problem goal is to change the profit from 10 to 20. Okay, so if I am measuring the current performance and if I found that it is coming around 15. But the system is wrong. The actual performance is only 5. So instead of showing us 5, because of a poor measurement system, is showing us 15. So I will believe that my current performance gap is only ₹5. So what will happen? Sometimes even the project management, the top management may reject the project because it is just giving only ₹5 improvement. No need for that. So you need to have a proper measurement system in place. Then only you'll be able to lead towards the correct direction. See, can anyone of you identify this particular image? Anyone? What is the inference do you got from this? You got from this particular image inference? Anyone of you?
The original decision and the actual impact, and that it wicket hitting.
So actually, yeah, the line in the yellow color line, it represents the actual path of the actual movement of the ball. The blue one represents the predicted movement of the ball. Okay, the blue one reports the predicted movement of the ball. So if you are able to measure the actual performance properly, you will be able to provide the proper projection of the project. You'll be able to get to the goal properly. So you need to measure the project properly. If you measure the actual performance properly, the umpire has failed to measure the actual movement of the ball, but the camera has captured, because that is a very good measurement system. Okay, so because of that, the camera using a technique is able to give you the future movement of the ball, predict the correct movement of the ball, the gap. So that is the importance of the measurement system. If you are able to measure the current performance properly using a proper measurement tool system, then you'll be able to project the future performance easily. Okay, so you need to give utmost importance to the measurement system analysis and how the data should be collected, whether the data collected is appropriate. All these things need to be given very keen importance. What are the steps which we are going to follow in this measure step? See, you are going to finalize the critical to quality performance characteristics. See, critical to quality is what you get from VOC, voice of customer, VOB, voice of business, and cost of poor quality. So we have to choose from that VOC, VOB, COPQ and get a CTQ, and you have to finalize which CTQ you have to attack, which X factor you have to attack. Okay, then you have to validate the measurement system. Why we need to validate the measurement system? If I say it in another term, you will be understanding that calibration is an easier term for people from industry to understand. You need to make sure that you have a proper valid measurement system. If only the measurement system which you have is valid one, is relevant to the particular data which you are going to measure, it will be a proper data. Okay, you have to validate that one. You'll be having tools to do that. You'll be learning that also. Then measure the baseline performance. As I told you earlier, if only we measure the baseline performance, we will be able to identify the gap between the current performance and the goal which we have fixed. So measuring the baseline performance using the performance indices like CP, CPK, capability indices, then sigma levels, then yield. All these things will help you to measure the baseline performance of the current process which we are working in. So in the measure phase, the 3 important steps is you have to finalize the CPQ. Make sure that the system which you are using for measurement is validated. If it is, say, all of us know from that example, the DRS is a properly validated system. That is why everybody is made to accept it. Likewise, we need to have a proper valid measurement system. Then after that, we go and measure the baseline performance. Without confirming the measurement system, if you go for measuring the baseline performance, the data which you may get may lead you to a wrong result, may lead you to a wrong decision making process. So you have to make sure that things are done properly. Then for doing those things, for doing those steps, we can use the following tools. Gauge R&R, it looks into the repeatability and reproducibility factors to validate the measurement system. All of us may immediately have a doubt what is repeatability and what is reproducibility. Dr. Ramakrishnan is waiting there in the wings to explain all those things for you. Okay, then histogram, all of us are aware of this. See, it helps you to get a visual immediate interpretation. Okay, by just looking at a histogram, we are able to identify the range, Okay, we are able to find out the distribution of the data. Then control charts, it is going to find out whether there is any abnormal causes, any special causes happening in our process. Then Pareto chart. So I am going to help you with this Pareto chart. It helps you to find out the problems where major problem is accumulated. Okay, then data collection plan is very important. A systematic data collection plan must be in place. Then only the data collected will be appropriate for analysis. Okay, then check sheets. Okay, we have check sheets which help you to find out the data in different patterns, in different process variations. Okay, then TOLLGATE review. It helps you to find out the key steps, challenges present in the particular process. So all these steps, tools will be used in different places accordingly to get the proper output from the particular phases. So don't worry, you may have a lot of doubts after looking into this tools column. Everything will be explained to you properly in the relevant and the specific time. So don't worry. Okay, so at the end of the measure phase, definitely you'll be getting a output, like you'll be having a MSA report. Okay, that is measurement system analysis report. See, you'll be having two analysis process. One is measurement system analysis, another one is AAA, that is attribute agreement analysis. Okay, depending upon the type of data which you are dealing with, you can choose a relevant system. Okay, then you'll be having a baseline performance measured. Okay, so definitely we need to measure the existing performance. Then only you can check where we lie and what is a gap in the process, and then you can go ahead and analyze how to improve it. All these things can be done. So at the end of the measure phase, you will be having a report generated from the measurement system analysis, which is very important to check whether the system is correct, adequate, capable, everything. See, based on the measurement system only, you can go ahead and measure the baseline performance. Without a proper MSA report, definitely you cannot go to the next stage of measuring the baseline performance. See, for example, here we have a measurement system report. Here you can see at the, just look at the end column, don't look at the remaining things. You may get a confusion. See, at the end you can see the 4.27. Just follow the cursor. 4.27, 4.27. See, the error must be within 10%. Then it is acceptable. Then the data which you have collected is a reasonable one, a proper one, a reliable one. If it is more than 10, then you definitely have to put that data in the trash, because that data is invalid one. Because the equipments or the system which you have used has not been properly calibrated or not relevant to the collecting the particular data. Suppose if the data is more than 10, we need to find out where the error lies in the data collection system, where the error lies in the measurement system. Then you can use a plot the data in the charts like this. Okay, you can use a R chart, or you can use a histogram chart, or you can use a X bar chart, or you can use a scatter plot, or you can use a box plot, or you can use another X bar chart for the operators. All these charts will help you to identify where the error lies in the measurement system, whether it is in the operator, or whether it is with the equipment, or whether it is with the machineries. It will help you to find out those things. Okay, so imagine, remember, if the error in the MSA, if it is more than 10%, the data which you have collected is not worth to analysis. It's not worth for calculating the baseline performance. Okay, this is a simple background information which I can give you now. So you will be calculating this MSA reproducibility, repeatability error and everything in the coming sessions. Don't worry. So the error, the gauge R&R error must be less than 10%. Then the data collected is a valid one. Okay, another thing to speak about is NDC, number of distinct categories. Okay, if it should be more than 6. Okay, the number of distinct categories should be more than 6. Then the measurement system which you are using is also a very good one. That is what I can say for now. Okay, you will be calculating this NDC also. That is number of distinct categories. That is, okay, that is for example, if my gauge is able to find out more number of, if you're able to measure more number of data in a specific range, if it is not repeating the same data again and again during measurement, okay, if it is able to give different distinct categories, then I can rely on that particular measurement system. Don't worry, definitely you will have a doubt now. Don't ask now. Keep the reserve those doubts. Everything will be cleared in the coming sessions. So the error, measurement error must be less than 10%. when you check using a gauge and R, the NDC must be more than 6. Okay, remember these two data, less than 10%, more than 6. Then you can go ahead with a particular measurement system and measure the baseline performance, and then you can check the gap in the performance. Okay, so as I told you earlier, that depending upon the type of data which you are working with, you have to choose a proper measurement system analysis. Okay, see, for example, we have two types of data: qualitative data and quantitative data. Okay, for example, so let me give an explanation in a traditional manner instead of a more sophisticated way. See, for example, how many people are present in the training now? Any one of you?
23.
Okay, it is a definite one. It is a definite one. So quantitative. Okay, so it is a discrete data. 23. You cannot say it as 23.5 or 23.6. Okay, so it cannot be set as a continuous data. It is a discrete one. Okay, so for example, if I ask what is the time, what is the information you can give it to me? What is the time now? Exact time. Anyone of you?
19.
Keeps on changing.
Keeps. So that is another thing. But I have to measure it now. What is the time now, please?
19.
Okay, it is just let us say it is 4.1 minute and 29 seconds. If I want nanoseconds also, it is possible. So a continuous data is a measurable one, a discrete data is a countable one, which is a easy way for you to understand. Okay, qualitative data is one just a brand. So basically you have qualitative data and quantitative data. Qualitative data is just a color. Normally we used to call it as common noun or proper noun. Okay, but quantitative data is normally used for analysis. In quantitative data, we are having discrete and continuous. Discrete data is normally a complete one, that is countable one. Okay, continuous data is normally a measurable one. It can be measured more accurately and it is changing. Okay, the thing is, as someone of you told, it keeps changing. Okay, it doesn't have a proper, it doesn't have a fixed variable. It keeps on changing. Likewise, the year fall, okay, the weight of the student, okay, and the amount of income tax paid, it keeps on changing. Okay, so this, using this type of data, we can analyze, okay, in the measurement space. See, now we have small exercises. I want all of you to participate. So we have some data types. So you people have to choose what is the data present here. Okay, now let us go with the first one. Width of the sheet. What kind of data? It is continuous or discrete?
Discrete.
Discrete.
How?
You have a fixed length or width.
It is not going to change. It will be the same value.
Say, for example, if I measure the data, whether it will be okay, what will be the example? Give an example. What is the width of the sheet?
4 mm, 2 mm, yeah, 0.4 mm in this case.
Okay, if I measure it more accurately, what will be it? 4.15. It will be like that, no? There is a
Into decimal.
Yeah, it can be measured in decimals in a more continuous form, right?
Yes.
So it will.
Yeah, Ravi, 1 minute.
It
So
will be
the measurable characteristics are called continuous data. Countable characteristics are called discrete data. Like Ravi asked, how many of you there on video? Now there are 9 people on video. So how do I know? By counting. So when I count and get the data, that is called discrete data. But when I measure and get the data, that is called continuous data, right? And continuous data, another way of defining continuous data is when you expect you are reading from a starting point to ending point. Let's say you are producing a sheet. The width of the sheet can be somewhere between 100 mm and 200 mm. Now between 100 and 200, how many values are possible? Will you be able to make a judgment correctly? The customer requirement is 100 mm to 200 mm sheet. And now you are producing several thousand sheets. Now you only have the clue. The values will be between 100 and 200. Now how many values are possible between 100 and 200? Will it be finite or infinite?
Infinite.
infinite. And so the data is called continuous data. There is endless. You know, there are infinite number of values. But suppose I want you to rate the training program from between 1 and 10. Now, how will you rate the training program when it is from 1 to 10? Either you will give 1 or 2, 3, 4. Only you will prefer to give it in whole number, isn't it? And then 1 to 10. How many possible values are there between 1 and 10? Exactly.
10.
Exactly 10 possible values. Now the number of possible values are finite or infinite? Finite. The moment you understand the number of possible values are finite, it is called discrete. But if it is infinite within the range, then it is called continuous. But to easily understand, any measurable data is continuous. Any countable data is discrete. Clear? Temperature. Now tell me, temperature, is it a continuous data or discrete data?
Continuous.
Temperature is measurable, right? And number of parts rejected, is it continuous data or discrete data?
Discrete data.
That's all. Now you go ahead with the exercise. Now, first one, width of the sheet. Tell me, is it continuous or discrete?
Continuous.
Yeah,
Continuous.
continuous. That's good. What about the next one? Number of liners.
Continuous.
Number of liners. See, you have to.
Discrete.
Yeah, number of liners. It is a countable one. You can have a finite numbers. Okay.
Yeah.
The discrete.
Okay. Then third one, number of tubes rejected.
Discrete.
Okay. What about the compressive strength?
Continuous.
Because it is a measurable. Okay. Number of infinite values may present between a range. Okay. Then saturated fat content.
Continuous.
Sheet thickness.
Continuous.
Okay. Remember, read those things carefully. Out of 100 sheets, the numbers that meet the thickness plus or minus 4.09.
Discrete.
Discrete. Because the requirement is to find the numbers. Okay, discrete. Then color is consumed.
Discrete.
Continuous.
No, it's consumed.
It can get
Continuous data.
Continuous.
Continuous. Because you can have infinite values between two ranges. Okay, depending upon the requirement, you can keep on increasing the values from 9.156, 9.157. You can keep on adding the values. So it becomes infinite. Okay, then last one, number of bugs in a program. Because it is a finite value. Okay, so now I believe you are able to understand continuous and discrete data.
Ravi sir, since there are a lot of doubts, so better let us take their questions, right? And we'll clarify now itself, and then probably we can take them through this run through slightly later on. Okay, so what are your questions? Let us clarify instead of moving forward with all your questions pending. Let us clarify your question. Somebody asked, right, whether the data is worthy for analysis or not. Am I right? That was your doubt, previous doubt, I remember. Whether the data collected is Ravi sir, can
Adequate.
you adequate? Show me that question, Ravi sir. Yes. What is that question? Is the data collected is appropriate for analysis? The data is considered to be appropriate for analysis if it is collected without error. If you collect data with a lot of error, will you still like to use the data and conduct your analysis? Definitely no, isn't it? So when the moment you understand there is a lot of error accumulated in your data, generally we don't prefer to use the data. So this is the meaning there, is the data collected is appropriate for analysis. At the same time, any time you collect the data, definitely error will get accumulated. Anytime you collect the data, error will definitely get accumulated. Whether you are collecting the data or I am going to collect the data, definitely there will be an error. We can't eliminate the error because variation cannot be eliminated. Variation is otherwise called what? Error. When I am measuring 100 mm, I will record it as 100.1. Now, is it not an error? It's a variation. Instead of 100, I write it as 100.1. Now it's a variation, it's an error. So this is called measurement error. This is called measurement error. So your data can come with.
Can I come?
Yes.
See the question, do you have an appropriate data collection plan? That was the question, right?
No, not that. The next one. Next one.
Yes.
Question is not that.
Data collected is appropriate for analysis. That is the
Yeah,
question.
is appropriate for analysis. Okay. Now, I am asking you to find out the health of all the 20 people. I am collecting the data to find out the health of all the 20 people present in our group now. Now, I am asking you to find out the weight of everybody so that I can say whether the people are healthy or not. Now, is this data appropriate, or Shivakumar is saying, no, RK, you ask them to find out the weight, also their height. Which data plan is appropriate? Can anyone tell me? I am telling you only find out the weight of all the 20 people. Whereas Gopal Shivakumar is telling, no, RK, I am going to ask them to find out their weight as well as height. Which data plan is appropriate for analysis to find whether all the people are healthy or not?
Measuring the health, other parameters also may impact, sir, except the
Yes,
health
both
and
are
height.
important. Height as well as weight. That is what we are meaning, that the data collected is appropriate for the analysis or not. Only weight, we can't do any analysis. Only height, we cannot do any analysis. Only the height and the corresponding weight are required for appropriate analysis. Thank you. Is it clear?
Yes, sir.
Okay.
So if at all any measurement error, it should be less than 10%. That is the industry requirement. So what is this 10% and how to measure the measurement error, you are going to learn, right? And is there any other question you would like to?
Sir, one thing, sir.
Yeah.
Sir, the second one, is your measurement system capable and adequate? And the fourth one is the data collected is appropriate for analysis. Is both are likely to be similar one?
Correct. You are right. You are right. Likely to be same, but the second one, it is going in detail. A measurement system is considered capable if it collects data without error, or if at all there is any error, it should be under control, right? Less than 10%. And also the measurement system is considered adequate if it gives you sufficient number of readings within the preferred range. Sufficient number of readings within the number of range. For example, morning you take breakfast. What do you take in the breakfast?
It's
idli.
Yeah,
idli. Right? If the idli is healthier and tastier, now you like it. So you want the idli to be healthier as well as tastier. But I give you only one idli. Is it adequate for you?
No.
So you need how many you need at least?
At minimum 3.
Minimum 3 you want. So adequacy is also important. Capability, ability to fulfill the requirement is also important, right? So same way when you collect data from, let's say from 100 and 110, all your readings are going to be from 100 and 110. Within the 100 and 110, how many readings are your system is going to give you? That will talk about the adequacy. That will talk about the adequacy, right? And suppose if my resolution is 0.1, between 10 and 11, how many readings are possible? When the resolution is 0.1, only 10 readings are possible, isn't it? So suppose if my resolution is 0.5, I will hardly get 2 or 3 reading between 10 and 1 and 2, something like that. So adequacy is also important, and ability to collect the data without error is also important. This is what we mean it. We call it capability and adequacy. But don't let us not try to go very deeper. But at the outline level, you understand, that's good enough at this stage. Because we are going to make you.
Sir.
Yeah. Yes, sir.
Sir, can I come in? Sir, is your measurement system capable and adequate? That's the question, right? Is your measurement system capable and adequate? Now, I'll tell you an example. My wife wants me to measure the length of her sari. My wife wants me to measure the length of her sari and accurately. Then I have got 2 options. I have a scale, I have a tape. Which one is the best measurement system? Can you tell me? Should I measure using a scale, 1 meter scale, 12 times, or I use a scale, tape once for all and measure it?
Tape.
the tape. Very good. That's all. Right. We are going to study in technically later.
Okay.
Thank you. Yes, sir. My job is over unless they have another doubt.
Yes, I will call you back.
Okay.
All right. So any other question you want to get answered?
Now I will ask a question if they are free. Now,
Yes.
can I call this output as a response? Can I call this output Y as a response factor? Yes or no?
Yes, sir.
Very good. That's
Yes, sir.
all. We usually refer it as response factor. Thank you.
Ravi sir,
Yeah.
I think we can. I will share my slides now.